Okay, so today we're gonna talk about fine-tuning AI models. Now, before we dig deep, and we're gonna start off with the interesting stuff, but I recommend that you stick till the end because at the end, I will tell you why it matters to everyone to know how to deal with AI models in general and how to specially fine-tune your AI model. And today, what I have for you is actually a system, an open source project that I stumbled upon that will make this a super easy process. And here I'm talking about an open source project that you can find on GitHub or their own website called Transformer Lab. And what we're going to do today is we're going to look at their open source project. We're going to actually run it on my Mac Studio, and then we're going to look up a model that is small that can run on my Mac Studio with all the applications that also are running on my Mac Studio while I'm recording this video, and then fine tune it to a database on Hugging Face and see the results. So if you want to be nice to me today, hit that like button. If you enjoyed the episode, please consider hitting that subscribe button as well. And with this and without any further ado, let's get started.
Subscribe to Daddy's channel. The mic.
So to start with, I want to show you my Hugging Face account. There's no genius work here, but I am recently doing and spending more and more time either building small models from the scratch, at least trying to, or actually fine-tuning models. Fundamentally, there is no way that you can actually learn AI better than actually getting your hands dirty and doing something for yourself and trying to learn as you go and read about all of the concepts that you have to understand to be able to fine-tune a model. And this is our open source project. It's called Transformer Lab app, as you see here, and it has significant attention on GitHub. So this was forked 450 times plus, and it was starred 4,500 times. I don't think you need to fork it unless you want to contribute to the creators. But here you can go through the repo if you're interested in the files and the code base behind it. But if you go down here, you can read all the details around the project. And if you click the banner, it will take you to their website where you can actually download the application of Transformer Lab. So if I click at it, it will take us to their website. And again, very simple, very nice done website. You can actually click on this link. It will take you back to the GitHub. There's a Discord server if you want to chat with the team and others who are using the platform. And here simply you can click get started and download Transformer Lab on your machine to start working with it. Now I have done that myself and I will just show you how the app looks, and we're gonna run a fine-tuning pipeline together. Very easy. Using the tool, you're gonna see how smooth it is. Hopefully, when the job is done, we're going to test the model and see how it works. Now, before I jump to Transformer Lab, I want to show you the dataset I'm going to use for fine-tuning. This is a contracts dataset. If you want your model to be much better in understanding contract law, contracts language, you would consider this dataset to fine-tune your model. So for you, feel free to go to the datasets section in Hugging Face, find a dataset for an area that interests you, where you want the model to be better at or trained to have more expertise in that area or more knowledge in that area, and you can actually use that to fine-tune the model. You do not need to download or do anything here. Everything will happen on Transformer Lab. I'm just showing you that on Hugging Face is where you can search for datasets, select the one that you like, and then work with it through Transformer Lab. And the same goes for models. So on Transformer Lab, you can download so many models out there. But again, if you want to look through these models, you want to search and see what's out there, especially when it comes to open source models that you can actually fine tune, this is the place to go. Again, everything will happen on Transformer Lab. You will not touch Hugging Face beyond just the search. And when you download and install Transformer Lab and you open it, this is what you will see on your local machine. Now, there is two ways to run Transformer Lab. What we're going to do today, we're going to do it on our local machine. Hopefully, my machine can take it with my software running to actually capture the screen, capture the camera feed. Hopefully, I have out of my 64 gigabyte RAM or integrated RAM on the Mac Studio some space to run a small or fine-tune a small model and then run it. But also, if you do not have that, do not worry, you can actually connect it to a remote engine. So if you deal with things like Lambda, where I've tested it before, where I rented actually 8 GPUs to try to create a model, you can actually run an instance on Lambda, then put in your IP address here and start running your whole pipeline through Transformer Lab. And I guarantee you, this will save you lots of headache and time if you do not want to go into the code level and try to build the whole thing yourself. So for us, let's go back to the local engine. And here we're gonna connect Transformer Lab to the machine. Again, this is running some dependencies and libraries that are already automated into the flow of Transformer Lab. You have to do nothing but click connect, and now it's running. And we are welcomed with this, I guess, AI image, which is interesting, but also a super smart welcome. So it's telling me, let's start with your next experiment. Get started by downloading a small model from the model zoo. So here is the menu for the tool. So we have the model zoo here, and it's suggesting Llama 3.2 1 billion parameter instruct 4-bit. So this is a quantized model, MLX. Could be a great starting point for your Apple Silicon Mac. After downloading a model, you can then run it by clicking on Foundation, then press Run. Once a model is running, you can chat with it by clicking on the chat icon here, and then fine-tune a model by clicking Train. So we're gonna fine-tune a model, then run it, then chat with it, okay? So let's go and start with clicking this button here, which is the model zoo. And you can see here, we can search for the models. Local models, I have none. I didn't download anything yet. And then generated, I guess this is when we fine-tune the model, we're gonna get the end result here, and this is the model store. Now, the nice thing I loved about Transformer Lab, I don't know if it's clear on the screen, but I can try to zoom it later, but here I have all the metrics from my CPU, my RAM is used at 53%, my VRAM at 32%. So this is all part of my Mac Studio RAM and the VRAM within the Apple Silicon. So let's look for a small model, either I'm thinking Quinn or what they recommended of the Llama 1 billion parameter model. So let's search here for Llama, and I can find the category of Llama here. I'll click it and I get all the Llama models here. And you can see this is the model that they recommend, and it's around 700 megabytes. Compared to, for example, the 70 billion parameter version of this quantized model at 4-bit, it is around 37 gigabytes. And I'm nearly sure that with everything I'm running to record this video, my Mac Studio has no chance in running this model. So we're gonna work with something small, and these small models, believe me, are interesting. They're getting more interesting every day and more powerful, and probably they will be a big part of the future. So let's download this model, and once it's downloaded, we will hop off to get our data, again through Transformer Lab, and then go to start our fine-tuning job. Okay, so the model is downloaded, and by the way, you can import local models by clicking this button. Or as we said before, we can go to Hugging Face, find the model that we like, maybe it doesn't show here, and then simply paste the link for that model in this part and download the model directly from Hugging Face. So you have all the options to deal with any model of your choice. Now, if I go to local models, we have our model here. So we know we have it, and that's a great start. So now let's get our dataset. So here you will find a tab called datasets. So this is super obvious. And like it goes for models, actually for datasets, you can either download a model from Hugging Face directly here through putting the link, which is basically, to show you in a second, this is the part that you need when you want to get something into Transformer Lab, either a model or a dataset. Simply hit this copy button, and you're good to go. So for example, if I want to, actually let me delete it. I will delete the dataset and I'll re-download it. So you go here and you hit paste, and then you hit download, and automatically the Transformer Lab application will download the dataset. It's a 17 megabyte dataset. Or you can add a new dataset locally from your machine. So you have all the options at the tips of your fingers. It doesn't get easier than this, believe me. Now we have the model, we have the data, let's go to train. So here on the top, you have the Foundation tab, you have the interact tab, and you have the train tab. So now here on the top, I actually don't know the difference between the alpha, beta, and gamma. I think these are versions. So I selected alpha. So let's go to the foundations here. And here we can select this model and we can actually run it. The great thing that because this is an MLX version of the model, MLX is a machine learning library or framework that is made specifically for Apple Silicon. So fingers crossed, we face no issues when I run this model. So let's hit run here and it is running. So you get this nice message. I hit got it. Now it's running. Now I can go to interact here, the tab. I can click at it and then I can actually select the temperature. I can select the maximum length and I can talk to the model. So this is the system message I can set here and then simply I can write and type and enter something for the model. So let's start with what are the top important 5 contract clauses when buying a house. So something to test its ability around contracting. So something just to test its knowledge about contracts. It is fast, I can tell you that. And it gives me flood zone and flood map information, environmental and health concerns, land use and zoning, subdivision map, disclosure. Okay, nothing mentioned around cost, nothing mentioned around something else, payments maybe. Anyways, okay, so this is what it's telling us are the 5 most important contract clauses when buying a house. Now, let's go and train this model, fine-tune it fundamentally, and then we're going to ask the same question. Hopefully we see a difference there. I didn't like the answer here. I think it can be better. I think there are more important clauses when you're considering to buy a house. For example, the price, setting the price very clear, setting any other hidden costs very clear in the contracts. That should be more important. Now, don't get me wrong, this could be limited by the ability of the model and not the data. So it might not change when we train it, but also if you fine-tune such a model, you might actually get better results. So let's go to train here. We'll hit train and we'll click here in new training. And here we have a small pop-up telling us select a training plugin from the following list. We have only the Apple MLX LoRA trainer. We'll select that and we can go through the details. So this is the introduction. It just tells you the models it can work with, the name. So you can give the training template a name here. So I called it Contractsman. And then we go to the datasets. Let's start by selecting the dataset. So we have only one dataset and the data is loaded now. And you can see it has 22,450 rows. So it's a good amount of data in one dataset. So having it loaded, let's go to the data template. So here, as we prepare the data template, you have to read the instructions here very carefully. And here I actually went to Claude just to confirm. So I fed it the dataset. I'm using the Hugging Face connector. And I asked it that I'm using Transformer Lab. I am dealing with the Jinja 2 standard string template format to fine-tune the model. And this is what I did. I didn't add the .text here, the .text 0, but actually Claude, looking at the data structure in the training data, told me actually you have to push it this way. So it's a good idea that you work with something like Claude before you actually put the formatting template. These models are, especially Claude, are very good when it comes to these things, and it will definitely help you a lot when you are building such a training template. So for the most part, we are ready. And just to confirm what we've done, in the bottom part here in blue, you can see there's a preview template output. So we can see here we have a contract. So this is coming from here, the context. So this is a complete contract clause. Actually, it's multiple clauses. It's a full complete contract. And by the end, we have the question, highlight the parts, if any, of the contracts related to document name that should be reviewed by a lawyer, details the name of the contract, and then there's an answer, distributor agreement. So this is what the model will be trained on. It will see the whole clause, it will get a question tested on the model, and it will get an answer. So this way it can actually fine-tune itself. Now I'm assuming that automatically this fine-tuning data will be split into training data, testing data, and validation data, or only training and testing data. Let's see. But for the most part, our structure should be correct and should be ready to go. Let's look at plugin configuration. Okay, so these are not within the purpose of this episode. These are things that you can look up yourself and you can go through them If you want a dedicated episode where we dig deep into each of these kind of parameters or concepts that you need to know when you are fine-tuning or building a model, please write me a comment in the comment section. I am more than happy to do a complete episode on that if you see benefit in it. And let's go finally to the sweep configuration. So this is, for now, leave it blank. If you want to run what they call hyperparameter sweeps, is basically you can give each of the same parameters we looked at in the plugin config multiple values. So as the model is being fine-tuned, the training run can actually try different settings of each. And if you are connected to something like weights and biases, you can see the outcome of each of these attempts and select the best version out of it. We are good to go. So let me save the training template now. And now I'll hit Q and the training will start. So I'm gonna let it run. And by the end of it, we're gonna run the model and ask it the same question we asked the original base model and see if we get a better answer. Okay, it took more than 3 hours and it's complete. And by the way, all the time I had to shut down my applications just to speed it because my VRAM was running at 100%. My local RAM, so this is part of the integrated system that I have with the Mac Studio, was running at 95%. So this small model, pretty much the fine-tuning job, maxed out my machine, but it's done, and as you see here, it's complete. So let's take a look at the TensorBoard, which shows us the results of what we've done now. And this is what we have. So this is the evaluation and loss, okay? And we can see the loss started, at least here where we can measure, started at a value of 1.9, okay, at 200 steps here. And at the end, at 1000 steps, we ended at 1.793. Now, this is expected from a fine-tuning job. This is not a full training, so this is not necessarily a bad thing. But again, before we test the model, I just want to highlight, if you remember, when we did the configuration, I didn't manage or change the max tokens. Now, I didn't want to spend 24 hours actually running this training. This is just for the demo. If you remember, when we looked at the sample, the context or the contract clause itself was a huge chunk of text. Now I have limited number of tokens, so probably the model was truncating these chunks of text to the maximum number of tokens that I had. So that will affect the model's ability to have that full learning. Still, it did learn something, but probably it's not the right way to do it if I want to do it myself. So again, this is the place where you go in and inspect your model after your fine-tuning is done. We have all of the information here. Now let me show you the output. Again, it's done, the run is done, so you can just go and watch what happened. You can see it's scrolling through all of the training. No need to actually go through that, but if you see those long text here, you can see it is truncating my text. As I suspected, you can see here this will be truncated to 2048. Which is in the configuration, in the default configuration, that's the limit for the tokens, okay? And the last thing which is important is the checkpoints. So if you click here, these are all the safe tensor files across the fine-tuning jobs, and this is their sizes for each one. Now, if I have issues in the training and I want to pick up from a certain point in the training, again, these are all the runs, the iterations, as we've seen from 100 up to 1000. I can pick up at a certain point and continue or restart from that point on. So I don't need to retrain the whole model if something goes wrong or I decide to change something. Now, let's go for the real test. Let's actually run the fine-tuned model that we have and test it for ourselves. So let's go and see our model zoo again. If I go to local models, and here I find my fine-tuned model. So it's here, it's appearing. Now the only thing we need to do is run this fine-tuned model and test it again. So let me go back to foundation. Here we have the old models. This is the base model that we tested. I'll eject the model. And now I'm back here. I can see again my fine-tuned model. I'll select it and now I can run it. So let's run it and start chatting. It will be one prompt, the same prompt that we did last time, just to test it. And it's running now. And if you note here, again, they did everything that you need out of such system. They have upload to Hugging Face. So I can now put my model out there for all of you to use, which we were going to do in a second. So all of you can actually download it and test it locally. I think most machines can run this type of model or this size of model. So let's go to interact and let's ask it the same question. Okay, let me tweak a little bit the temperature. I think I reduced it. I forgot exactly the prompt that I put, but fundamentally it is, what are the most important 5 clauses to consider in a contract when considering to buy a house? So I'll hit submit and let's see the kind of response that we get. And definitely it's a better result. This shows you the importance of really understanding how to fine tune. The purchase price clause, the inspection clause, the financing clause, things that I already mentioned just hypothetically what I would consider important. The closing clause and the title clause. So when the title will move to you when you are buying a house. So the result is definitely making this model a better one. For sure, it's a better one in the way it answered, especially for a small model. So great result. I'm happy with it. So let's go back to the foundation. Let me upload this to Hugging Face. So I have put the basic information they asked to upload to Hugging Face. And now let's hit submit. Okay, and I have the model uploaded successfully. So we are done. We uploaded the model. We trained the model. It's working. Again, I will give you the link. You can go to my Hugging Face. The link is on my website, everywhere you go. But I'll give you the link in the description if you want to download and test the model yourself. Okay, now I'm back to my Hugging Face. And as you can see, we have the Transformer Lab contracts, 1 billion parameter. Let's just quickly check it out. So they put like a template placeholder for the model card. We can fix that later and modify it. If we look at the files, actually it integrated the whole model. So there's 2 ways of actually publishing the model. Either you kind of describe what is the foundational model that you're dealing with, that you fine-tuned, and you just put the LoRA file, basically the modifications to the layers that were fine-tuned from that model, and people can simply get your LoRA and then load the actual base model, and then that LoRA or low rank adaptation can actually get you to experience the model, or it can integrate the whole thing and push it as a single model. This did the second. It actually integrated the whole thing in a single model and it pushed it. This is basically the model.savetensors here, and using this you can simply download it and run the model. And by the way, you can easily do it through downloading the file, loading it in Transformer Lab on your own, and then running it. So you can run the model and actually inference with it locally. This is a small model. Most machines will be able to deal with it. So now, if you stuck till this moment, thank you very much. The most important part, if you skipped this part, it's up to you. But the most important part that I didn't want to put it in the beginning where people probably will drop off the video, and I kept it till the end for the serious people who want to really hear what I have to say about why would learning how to fine-tune be so important. So let me explain to you with a nice diagram. Okay, so the fundamental question, why did I am still trying to learn how to improve my fine-tuning, maybe work even with bigger models? Why would you be interested in doing that? Well, there's multiple reasons. Some reasons are for people who are the general public, anyone out there interested in AI, and there are reasons that have to do with people doing furthermore, building applications, building systems to do such a thing. So benefit for everyone. So this is what most people should consider of why it's a good idea to learn how to fine-tune. Deeper AI literacy, I guarantee you. So I'm on that learning journey. My whole YouTube channel is my learning journey. I try to read things, break things down, explain it to you. But nothing, I feel, gave me an understanding. Maybe I'm not perfect in articulating that understanding yet, but in my brain, things are connecting like an AI model better when I went into actually building a complete model or fine-tuning a model. It's very tough to do, but when you experience something like that, you will have to understand terminologies. So if you remember in the configuration, there's lots of terms. You're going to have to go in, look up each one of them, what it means, and it will put you on a pathway to learning AI, I believe, better than any course will give you. Okay, better problem solving. Again, I think this is not unique for model fine-tuning or development. but also for anyone building something, especially in software. I vibe code. I'm not a software engineer, but I am an engineer. So this is kind of my DNA, I believe, at least I tell myself in the mirror. But doing these things, if you vibe code a project, if you build something, if you try to analyze a problem, mathematical or otherwise, it will help you in a way fine-tune your brain to be a better problem solver in life, in your career, in everything. So definitely an interesting experiment to go into. But also, when you are trying to get something out of an AI model, not always, as we've seen here in this experiment, not always you get what you want from these AI models. So you want kind of an AI model. For example, let's say I'm not building an application, but I'm using AI like ChatGPT, and I'm using it for contracts for my work. It is not satisfying what I'm looking for. So what I do is I actually can fine-tune a model to be perfect in contracts. And then when I use it daily, it will give me the outcome I'm looking for. So this is even a cherry on the top. Control and customization. I mean, there's nothing better than having more control over the models that you interact with. We can spend hours actually discussing applications and how fine-tuning will benefit those applications. Again, career leverage. I mean, this is again one other personal bet I have in all what I am doing on late nights and weekends. I believe that me doing this, and hopefully you doing this, and talking about it publicly, will at some point, as AI is getting more and more important in business and in career, people are talking about reskilling and upskilling. Well, you're doing it the right way. If you fine-tune models, if you talk about them, show people your work, explain how you did the fine-tuning job. And Transformer Lab is a great starting point because it's your window to do anything from super simple like we've done here to super sophisticated. You can actually do more. And if you go to their website, they are even developing Transformer Lab to do super serious stuff. So someone watching this video, hopefully one day, would send me a note that this inspired them to do something crazy, something I hear about on X or on the news. So I believe it will help your career, hopefully even build something on your own. Now, the second group is actually people building something. When you are building an application, most AI applications out there, and people talk about it openly, are what they call AI wrappers. Basically, you have a standard model like ChatGPT or Gemini or Anthropic, and you build some functionality, some API calls around it, and you make an application. That's good. You might make money, it might succeed, but your app will always be susceptible to failure, susceptible to model changes, model behavior changes. Anyone can beat you because there's nothing special about what you're building. Unless there's lots of talk around this, but unless you build a complex ecosystem around that standard model, so you build a whole environment very complex to replicate, then maybe that's a different story. But for the most part, the heart of that application, that AI application, is the model. So if you have a unique data set, or if you combine a great model with a unique data set, either you acquire or you have yourself, then you have a special model that will be probably very hard to get by others. That by itself could make whatever software you are building super special, and people cannot compete with that. So people can replicate the wrapper, they will not get the same results because your model is fine-tuned. It is your version of that foundational model or base model. So this is, in my opinion, one of the most important skills for people building AI applications. At least consider the chances that you might improve your application by fine-tuning a model. So this is a major part here. Again, differentiated user experience. If you're building, to our example, if we're building an application that helps people with contracts, actually the user will have much better results than anything generic out there, because I will put in my application a model purely made for contracts. So I can differentiate, again, going to the first point, I can differentiate my application compared to everything out there. Higher accuracy and consistency goes to the same point. Performance and cost control. Again, you can manage the performance of the model because you fine-tuned it. Also, you can manage the cost. So rather than getting a big heavy model and run it on a virtual machine and paying all of that money for my AI application or paying for APIs, I can actually get a 1 or 2 or 13 maximum, I would say, billion parameter model, fine tune it to my need. Actually, the smaller one would work perfectly, and then deploy it for my application. Then I don't have to pay for all of these API costs. I don't have to actually work with a heavy model to pay all of that extra unnecessary load on my application, and I can manage my cost in a really efficient and optimized manner. Again, going to the first point, product IP, not just UI. Training data and weights become assets competitors can't copy. So this is my intellectual property. So I'm not just putting a kind of a fancy user interface and behind it is ChatGPT that everyone builds on. I have something different. And lastly, if this matters to you, which is important depending on the area you operate in or build something in, better guardrails and safety. You can bake in domain specific rules, compliance, style, and constraints. For example, whenever you deal with contracts, I can put trade rules, trade compliance rules that affect most of the countries. So I ensure that the model never recommends something that doesn't comply with compliance laws. So I can do that. I can, by the way, double fine-tune my model to make sure it has all the elements that I want to build into it. Okay, so for me, it was an amazing experience. So first and foremost, thank you for Transformer Lab team for, I don't know how they get to my super small channel and consider me for this or ask me to do this review. Again, I only do it because I'm interested in it and they did a great job. So keep it up, Transformer Lab team. I recommend it to everyone. This is the right way to actually tip your toe in the world of fine-tuning and models. It's interesting to the level that for sure I'm going to do a bigger job in the future, probably through working with things like Lambda and renting the GPU. So for a job like this, it should take minutes on Lambda if I have the right GPU. But also I can actually go after more ambitious projects. And if I'm building something in the future, I can actually create my own model through Transformer Lab. And it's a good way also to test open source models. I've never considered it before. Usually I go to the user interface of these labs, and I know some models don't have that. So this is an easy way, by the way, to test a model like mine. You can download it through the link in the description and test it on Transformer Lab. So I enjoyed it. I learned something today, and I hope you did. If you did, please consider hitting that subscribe button. Tell me what you think. Will you try Transformer Lab yourself and build something? If you do, please write me a comment in the comment section. And hey, why not share this with someone else? Maybe it will inspire them. Maybe put it on LinkedIn. I'm a little bit greedy here. I hope you enjoyed the episode. Thank you for watching and goodbye.
Subscribe to Daddy's channel. Give me the mic.